Okay. Welcome, everybody. I'm going to hand this show over to the BirdBrain Technologies founder and CEO, Tom Lauwers.
All right, welcome everyone. So today's webinar is about remote robots, and it is a presentation that I am doing with Erin Whitaker. Erin, do you want to say hello?
Hi, everyone.
All right, so I'm going to switch over to my slides. And I really want to tell you today about what remote robots are and how you can use them in your classroom and how you can make remote robots happen. So here's a link to the slides. Matt is going to put that link in the Zoom chat and Facebook feed so that you have access to them. There's a lot of links buried in the slides in different slides, so you'll have access to all of them. So I'm going to start by talking about what remote robots are, and then do a brief demo where you may get to program one of the robots that I have here in the Livestream Learning Studio here in BirdBrain Technologies office. Erin is then going to talk about how she used remote robots in the spring, and then I'll end by telling you at a high level 3 ways that you can make remote robots. So what are remote robots? The idea behind remote robots is, I'm here in Pittsburgh and I have some robots. I'm originally from Belgium and my family lives there. So how do I get my family to program the robots that are at my house or at my office? Or more generally, how do we get somebody who isn't physically present with a robot to still benefit from physical computing and programming real robots in real time? So how do we do that? So in mid-March, when schools were shutting down due to the pandemic, I was trying to come up with ways to make this a reality. And in the end, we as a team actually came up with 3 ways. But first I want to tell you about why we went with remote robots over doing something like a robotics simulator. So the first piece is that I believe that physical computing, when you are actually, or as the student, actually altering reality by programming something in the real world, has real benefits for engagement and learning. So if you're going to do robotics, ideally it would be an actual robot. Otherwise, I think most of the benefits of robotics are kind of lost in terms of computer science engagement and learning. The way I feel about simulators or simulated robotics is that they're not really different from software-only programming. And by software-only programming, I mean going to code.org or Scratch and programming an animation or a game. I think those methods are engaging and useful, but I don't see the simulator really adding anything above and beyond creating a Scratch animation in terms of engagement. Whereas I do see programming a real robot as going above and beyond as programming something like a Scratch animation. The other piece is that with respect to at least BirdBrain Technologies products, and especially the Hummingbird Kit, if you think about the types of robots that you can build with the Hummingbird Kit, they're just very highly varied, right? It's about creativity and creative robotics and design. And so how do you make a simulator that catches that captures all of that? Like, how do you make something that works with both a zombie robot that's roving around as well as this robot garden? How do you simulate both of those use cases in a piece of software? It just didn't seem particularly useful. So, and then the last piece is that if you have a simulator, how do you do the creative design component? When you are still engaged in designing and programming a robot, creative design, even pencil and paper design for your students is still possible. And Erin's going to kind of show you exactly how that worked in her classroom in the spring. So this particular webinar is the first in a series that we're planning that will probably go from August through November in terms of ways in which we are trying to help in this new kind of hybrid learning and remote learning reality that we're all in. And that series is actually going to go along 2 different strands. So the first is remote robots, which this is sort of the introductory webinar for. And the remote robots use case is really that you have robots, one or more, at your house or in your classroom, but your students are not with you physically present. And your students don't themselves have robots. So you want to figure out ways for your students to program those robots at your location over the internet. The types of webinars that we're exploring for this strand is to have a Finch Robot 2.0 open playground. So these are just sessions where you'll be able to come in, program the robots, really get into a deep dive of just like, how does this work and how do you program robots over the internet? And then I'll also be happy to do deep dives into specific methods for programming remote robots. So this webinar is going to cover 3 different ways that you can do this at a high level, but I'm also happy to do webinars that are specific to any one of those different ways. The other strand is for one-to-one robotics. So in this situation, everyone has a robot. So all the students have robots, probably the teacher has a robot as well, but you're all in different places. You're not physically located in the same classroom. And so you need to be able to teach your students and coach them and effectively, right? Like what kinds of tools can you use in this situation? And fortunately, we've actually seen quite a few educators in spring and summer who've run one-to-one robotics programs with the Hummingbird Kit in the spring and the summer, and they are going to share their stories. So that's a separate webinar series. Sorry, Matt, what was that? Okay. So they're going to share their stories, and Kelsey Derringer, who's on the call, will be leading those webinars. All right, so I'd like to do a brief demo with you all. I have several robots set up in the studio. I've got a smart house, a Jackson Pollock painting, a Hummingbird beetle. I also have 3 Finch Robot 2.0s, including one that has a phone mounted to it. And if you're on the Zoom call, you won't be able to do this in Facebook, but if you're on the Zoom call, you can actually click on Tom's iPhone and you can see the view out of that phone. So, oops, lost the presentation. Here we go. So there are 2 pages where you are provided with links that will let you program these robots. So I'm going to go to the Finch page, show you what that looks like. Okay, so this page actually has a 2-minute mini instructional video for how to connect and program a robot. The idea, in essence, is to click on one of the links. So I will click on Finch A, and that will open a project file in NetsBlocks, this is one of the ways to make remote robots. And so in order to connect to this robot, you would press the C key on your keyboard or hit when C key pressed. It'll say connected. And then there's a brief little example program that you can run right away. So if I run this, you may hear the robot has started to move, or if you look through the iPhone view, you can actually see it moving. Hi. And you can also, oh, lost the screen. And you can also start adding to this program. So for example, you can add, some blocks to make the lights light up on the Finch. Now, once you're done programming this, you hit the X key and that disconnects you. Now, one of the nice things about this particular way to do remote robot programming is that everybody can can open the programming links. So all of you, all 40 of you on the webinar right now could open these links and start editing, and you're not going to interfere with one another. So it's not like what you're doing is going to affect somebody else. Only one of you can connect to each one of these robots at a time, and there's only 6 robots total, so you may not all get a chance to program. But you can be assembling the program even while you're disconnected. So you can, you can do this kind of thing where you're moving blocks around even while disconnected. And so quite a few people can actually get on get into kind of a classroom where you have maybe 3 or 6 robots total and be programming them in real time. So going back to this website here, the links to the robots, if you're curious about how to program them, there's a blocks reference here and some tutorials here and some troubleshooting instructions if you run into any issues. And there's a similar page linked for Hummingbird.
And Tom, we had a couple of questions in the chat that I wanted to direct us to. Do you need 1 computer per Finch robot or 1 computer per Hummingbird? How many robots can you connect to 1 computer?
So that's a great question. With NetsBlocks, with the Hummingbird Bit or the Finch Robot 2.0, you can do 3 robots per computer. If you were using a Hummingbird Duo or a Finch 1, you would have to use 1 robot per computer.
Great.
Were there any other questions?
Yeah, another one was, how do you know when your program is being used by the robot and not someone else's? How do you know when you're connected, not somebody else?
So when you press that C key, if you, it will say connected. If you try to press C and somebody else already has the connection, it's actually gonna say this robot is in use by someone else. So you'll get sort of a message here. Now, one thing, you know, when we do like a half-hour to hour-long workshop where we're just focused on programming these robots, and I see actually the Jackson Pollock is already lighting up, which is great, by the way. If you're in that kind of workshop, what I ask people to do is in the chat, if they're using a robot and they disconnect, to just put in the chat, hey, the Beetle robot is now free, or hey, Finch A is now free, just so that people know that a robot is in use or is free also through that. Any other questions?
And there were folks just wondering, clarifying what language this is that we're looking at. Someone asked, can you do it with Python? But really, I think what people are wondering is, on your screen there, what language is that they're using?
So this is the NetsBlocks environment, and I'm going to talk about it quite a bit more later. And this is also what Erin used. NetsBlocks is based on Snap, which is itself based on Scratch 1.3. So it looks very much like an older version of Scratch, and it's got very similar concepts as Scratch. You know, you're pulling in blocks, you're using loops, and you're doing this sort of puzzle blocks analogy for creating programs.
And
Okay.
I just also want to invite folks, if you're not super familiar with Zoom, if you want to look at these different views, so if you want to look at what's on Tom's screen, or if you want to look at the hummingbirds that are set up or the finch that's set up, you can hold your mouse over someone's little square. So you could hold your mouse over the square that says Tom's iPhone, click those 3 dots and then say pin video, and that will make that big on your screen. So you can look at what you want to look at right now. Whether that's Tom's screen to look at the programming or the Hummingbird robots, you can see whoever is controlling the Jackson Pollock. It's looking pretty colorful and awesome. So make sure you mouse over that person, click those 3 dots and say pin video, and that'll get you to look at what you want to see.
All right, so 2 more questions that I see come in. So can you do this on an iPad? On your end, where you're with the robot, you have to use a Windows, Mac, or a Chromebook computer to connect. But on the student's end, they can use any device that runs a Chrome browser. So that includes iPads. And then I always have these 3 robots available, and how many hummingbirds? So these are only available during live workshops like this. I have 5 robots at my home that are always on that I try to maintain, and those have been running since March. And I'll talk about those a little bit later, but there's basically 2 different ways to use this technology. And so one is this kind of live workshop, and the other is sort of the asynchronous, always on robot. All right, so I'm gonna go back here, and you guys can continue playing with the robots, but I think we should move on to hearing from Erin about how she used this technology in her classroom in the spring. So Erin, take it away.
All right, thanks, Tom. So first of all, just so everybody knows a little bit about me, I am a middle school technology coordinator at Sewickley Academy. So I sort of have 2 roles at the school. I help teachers integrate technology. And so I wear sort of that coach or integration specialist role. And then I also teach some middle school level classes. So I teach computer science, robotics courses to 6th, 7th, and 8th grade classes throughout the school year. So that's sort of my role and my background in terms of what I've been doing. So what brought me to this is, as a class, I offer a course called Arts and Bots, in which we use the Hummingbird. And actually last year I had just gotten the new Hummingbird Kits, and we purchased a whole class set, which was great. We get 2 weeks into the school or into the trimester, which I didn't teach until the later half of the year. And everything starts going crazy, right? The coronavirus is becoming a thing. We go off on spring break, and then all of a sudden, halfway through spring break, everything shuts down. So I'm sort of stuck. I'm like, okay, well, what am I going to do? All the robots are at school. All my students are at home. And so what I ended up doing was, first I was like, well, let's see what's out there. So I actually went on Twitter and I tweeted to BirdBrain and Tom, and I said, hey, I have these robots. Do you have anything like a simulator? I know that was talked a little bit about, that I could at least get the students to do something on. And so from there, Tom had already been thinking about ideas and had their website built with his remote robots that were set up in his house. So I was like, great, this is a great start. So I actually had some students attend some of the webinars that BirdBrain put on and had them program some of those robots. And then I was like, well, how can I do this? How can I set up the robots so that my students can create, design, still have that process, even though the robots are at my house. And so fortunately, this partnership came about that I just kept digging in deeper and deeper. So what eventually came of this was what I called the Robot Dance Party Project. And so once I sort of had all the tools that I needed to sort of greenlight this project, I presented it to the students and I said, hey, here's what we're going to do. This is new to me. This is new to you. We're going to work through this together. And we created this Robot Dance Party Project. And so the idea was that the students had to design a robot and program it to dance along to a song. And that's basically the idea of it. And so I placed students into groups of 3. Fortunately, I had a really, really small class. I think there was only 9 students in this class, which ended up being a blessing the first time around. Usually I have more closer to like 16 kids in a class. But I was able to have them group in 3, which means I needed to get 3 robots up and running. They were grouped in 3 to build the robot, but I still held them accountable by each of them was going to write their own code. So even though it was 3 students per 1 robot, they all had their own code and own sort of dance moves that they had with their robots. So from there, what I did was I really focused on the design process as well as the collaborative end of things. And so I used Google Drawings as sort of a collaborative tool where they created a sketch of their robot. And so I used the breakout rooms where they broke up into their groups of 3. They each had their own Google drawing that they shared out. Or that I shared out with them, and so they all were able to collaborate together. I think I have a pitch on another slide here of what an example of what that looked like. But what is super interesting about this is how, especially at the middle school level, the discussion around details and how planning is an important piece to the design process. I had some students who were very generic in their drawings, and when I built their robot, and they went to program it, they thought that they had a tricolor LED that could light up when they only indicated just a single LED on their drawing. And so that discussion of how details are important came about. And so things like that, it was really interesting that these other discussions and other parts of it sort of came to the surface along with this. So after they designed the robots, I sort of scavenged through my recycling bin and started picking out things that I had, toilet paper rolls, granola bars, and created the robots to the best of my ability with the robot components. And again, I was able to actually go into school and get a couple kits and a couple computers to make this all work. So fortunately, I was able to do that and got them all set up. BirdBrain had a tutorial that kind of walked you through, and I know Tom will show you where to find those later on, exactly how to set up what is called the server client, or the server code and the client code. And so there's two separate parts. So the server code is what is needed on the teacher end for the robots to actually work, and the client code is what the students are using that talks to the server code to make it all work. But there's some great tutorials. And it took me, I would say, about an hour to kind of get it all figured out, put together, and get like a working robot with everything. One of the things to make this work asynchronously is to have a live stream. So I wanted my students to be able to work on this on their own time, so that I could troubleshoot a little easier. I felt that doing it synchronously, it was just going to be a lot of downtime and wait time for some students who were just doing nothing. And so having them able to do it on their own and then come to me when they had questions and schedule those office hours really worked well. And I actually used YouTube Live with a webcam to stream those live links. And so YouTube Live will actually allow you to stream something up to 12 hours. And so each morning I would start the live stream up, send out the link to my students, and then they would have access to that for 12 hours or so. Let's see, what other things. The tricky part with the live cam, though, is there is a time lag. And so this is something, again, another a piece that students had to problem solve, right? So it wasn't the end of the world, but it was a piece that was interesting because there's about a 15-second delay or 20-second delay from when the student hit the send, right, started their program, to when they actually saw it happening in the live video stream. And that actually was really tricky with the music piece because they couldn't play the music piece right away because of the lag. And so, again, it was another piece that really promoted a discussion around, well, what can we do to solve this problem, right? And so some students, actually, I think I had two students that came up with the idea of, well, what if we have the lights blink, and when the light blinks the third time, we'll start the music. And so they got creative with some ideas of how to make it work. Of course, there were other students that really struggled with that, and they're like, I don't know. And so I had to help them out a little bit more with what some strategies might be to do that. So like I said, they could work at their own pace, and this was over about a 3-week period. I scheduled some check-in times where the students would check in with me to see how their programming was going. Nets blocks, actually, I just learned about this, and this will be an added feature. There's actually a collaborate mode, I forget what they actually call it, where you could actually, it's kind of like Google Docs, where you can actually be invited to their programming and can be working on their actual programming, leave comments and edits right in there. I didn't know about that until actually a couple of weeks ago, but what I did is they would export their code to me, I would test it out, and then I would get back to them with feedback, whether it was an email or live or in their Google portfolio. So I had them keep track of their learning through a Google Slide portfolio. So every time they were working on their program, because they were working on it asynchronously, I usually had some reflection questions, and they had to talk about what they accomplished, what challenges they came across, how they overcame them, or if they didn't overcome them, what they need to do. So that was sort of how I held them accountable for what the learning piece was and where their struggles were. So I think that's what I have on that slide. Here's a picture of the actual robots I created. And as you can see, they are not fancy by any means. And so when you look at this compared to what BirdBrain has, they definitely have the artistic piece to this. But again, I was on a time crunch and I was putting things together last minute based on what I had. And so I've named them accordingly. And so you have QuakerBot, BelvitaBot, and NutriBot. And so what I did then is when I named them in the server, or the client code and the server code, I would just name it NutriBot client, NutriBot server, just to kind of keep things organized in some way. And so you can see there that there's lights, you can see there's some things attached to it by either a servo motor or a rotational motor. There are some sensors on there, and I'll talk about that in a few minutes here on what I did with that. But this is sort of the overview of what my 3 robots look like sitting in my basement for the last 6 weeks of school. On the next slide here, I actually have a video of one of them playing, and you can see on the top right, I actually have a little sketch, and that was the sketch that the students created, and that's what I created based on their sketch. And at the bottom, there's a little snippet of their code. I know that's kind of blurry to see, but I just wanted to put that there. But in a minute here, you should be able to hear the song playing with it, hopefully. Maybe not. Wow, it did work earlier, but there's a song playing in the background. And if you have the link to the slide later, you'll be able to hear it, and my 3-year-old also screaming in the background at times. But the idea is the lights are blinking, and when the music stops, it's stopping and changing direction. And so it's about 1.5 minutes of code that the students programmed to the song. And so it was a lot of trial and error. So again, that cyclical process, design process of trying it, making edits, trying it again. And so again, that's why the asynchronous piece was important to me, so that they could do it on their own time. And because there were 3 students for 1 robot, if I did it synchronously, there'd be a lot of students waiting for their turn. And so I thought the asynchronous worked well. So let me pause here, because I think there's probably some questions at this point that I haven't been keeping track of. I don't know if Kelsey or someone wants to ask some common questions they've been seeing.
Absolutely. Zoe had a question that I thought was really, really smart, which is, how were you able to see the students' code and see what they were doing? Because you could see their drawings because they sent those to you, and you could see their faces because you were on Zoom with them. But how could you see the code that they were creating?
So what I did was they would have to export and email me a copy of their code after each time they worked on it. So they were expected, my class was either once or twice a week. It wasn't an everyday class. So after they were working on it, they would send me the code, and then I would send them back feedback, either in the form of the email or a video conference. Now, I didn't mention that NetsBlocks itself actually has a collaborative feature now. So what I plan to use if I have to do this again is they can invite and share their code. And just like in a Google Doc, if you're familiar with that, they can be editing and you can be editing. So you can actually be in their actual code without them having to email it to you every time. So you could access it whenever you want and see their updates. So that's a really cool feature I just learned 2 weeks ago that I would use this time around if that's the case.
That's amazing. I didn't know about that feature, actually. That's so cool.
Yeah.
I feel I hope that is in the slides as well, like that feature. And if not, I wonder if you might be able to add that. But Anita was wondering about your class size. So how many students did you have in this class? How big were the groups that you had? And then maybe you could just say again, you were talking about synchronous time versus asynchronous time. So for you teachers who are like, oh, I've got 25 or 30 kids in my class, how could I do this? Can you give them some advice?
Yeah, sure. Like I said, I fortunately had a really small class. I actually taught 2 classes of this, and my first trimester class was really big, and this one just happened to be small. So I only had 9 kids in the class, which I know is super small for most people. Usually I have about 16 kids in a class like this, which would have been more challenging. And I think in terms of how much they would have accomplished, it may have been less because I would have had to spend more time either meeting with them or grading or whatnot. So your other question was, so a larger class, I think I mentioned this on my next slide though, I grouped them in groups of 3 because that just worked out. I could foresee that maybe even if it was done virtually, that the collaboration piece could have been done in groups of 4 or 5. So you could have had 4 or 5 kids to 1 robot and still had them each responsible for their own code, is one way to do that. So even if you had 3 robots, you could have 5 kids per robot, that's 15 kids. Or if you had 5 robots, 5 per, that's up to 25 kids. So it's doable, but it's definitely going to take more time in terms of reviewing their code, meeting individually. If that was the case, what I would probably do is block off specific time and say, these students are meeting this day. I would probably leave it a little less flexible in terms of the meeting times. I would say, okay, these groups of people meet during this time, rather than them like making appointments with me. I think I would have to do it that way, just to not drive myself crazy with all this time spending on it.
Yeah.
Was that all the questions? Was there another one in there?
Yeah, Karen was saying she's going to have up to 36 students in each of her elective classes, and your advice and mine are the same, which is just like do everything you can to make that smaller, whether it's breaking up your hour into 20-minute sections. So like 36 kids on a Zoom class is just terrible.
That's insane.
Like,
yeah, that's insane.
You can't see all their little squares on one thing even. You have to click around to see them. So if you're trying to do hands-on stuff, like you just have to find a way to make those classes smaller. You could potentially use breakout rooms or different things like that to get fancy with it. But it sounds like your big advice is like, do what you can to make the classes smaller, especially on Zoom. That's great.
Yeah, definitely. So the breakout rooms is good, but you still have to kind of be able to hop class to class. If it was me and I had 30 kids in a class, I would take my hour or whatever time I had, and I would say, okay, this group, let's meet for 20 minutes here. This group, 20 minutes here. That would be my preferred way. Again, it's different for every teacher, but I think the smaller the group, the better it's going to be. And I mean, they're going to get frustrated, and you're going to get frustrated at times because it's hard to troubleshoot virtually with coding, right? And so it can, I mean, I know in a class, sometimes it takes me 5-10 minutes for a kid trying to figure out what their issue might be. So I can see where that could definitely get frustrating. But I mean, if you can, rather than having the whole class for the chunk of time, I would chunk it into smaller groups and then have a asynchronous activity that they can do on their off time. So.
And there are a few more questions. Some of them are more technical in nature, and maybe they should be bounced off of Tom. However, Pam was wondering if the students were only able to see and update the results of their code if you were there to download it. Does that question make sense? In other words, did you need to be present to download the code in order for the students to see the result with your setup?
No, so the only reason I had them send their code to me was just so that I could review it. They actually, the greatest part about this is with remotely, as long as my robots and my live stream was up and running and the servers were all running, the students could remote in and see on the live stream. So what that usually looks like is they split their screens. They usually have their code on half a screen. The other half is the video feed. And so what they do is they do their code, they send it to the robot, then they're looking at the video and seeing the results of that. And again, it's usually a delay. So that's something that middle schoolers especially have to get used to, like wait time. They have no weight in their bodies whatsoever. And so that was an adjustment, like you gotta wait a few minutes. It's not that it's not working, it's just that it takes a few seconds for it to work. So at any point, as long as my robots and everything was working, they could go on at any time and check and see how the robot was doing. And the check-ins were to either troubleshoot, to check that they were getting things done, and for me to just check their progress and learning along the way. So they were doing it asynchronously along the way with the remote system and the video.
Fantastic, thank you.
Mm-hmm. Yeah, and so I think this is my last slide here. Let me just look at I got here. So just a few, I guess, takeaways here that maybe I mentioned, maybe I didn't yet. The biggest thing was for me was, and Tom sort of hit on this point, was for me, like robotics is all about that hands-on experience and like being able to actually physically manipulate things and program it and see the change. And while they didn't really get to build their own necessarily, I actually did like a one-day activity where they actually went and scavenged around their house and just built a robot. It wasn't really a robot. It was just sort of the shell of a robot. But they were able to do the design process, design it collaboratively, have something physical, even though it wasn't with them, but something that they could move, that they could see moving, that they could see the result of. And to me, that was important in terms of the integrity of the class and what the curriculum sort of said, because otherwise I was sort of going to have to wipe away everything that I had done in terms of the curriculum and change it to something totally different. Some things I learned along the way, though, one of the things is when you're dealing with motors especially, depending on the design of the robot, it's easy to break things. So if you have a servo motor, like I know in the one robot I had, the one servo would go back and forth with the wheels. And I kept telling the students, and this, I should have just set the parameters in the code. I just ran out of time of figuring out how to do everything. But if they put the servo and they turned it too much, it would snap off, right? So there is a way, and Tom will either talk about it or it's in the tutorials, how you can actually set parameters in the server code so that they physically can't actually like break parts of the robot. So that's something I learned along the way, that you have to be careful, even as much as I told them and put that in the comments. It's still good to have that fail safe so that your robots don't break. Again, I had a small class. Anything above 16 might require you to sort of break it off into 2 classes just to make it easier to manage, especially with devices too. I know I didn't actually have the Bluetooth thing. I had to plug mine in directly. So I actually had to have 3 computers with 3 robots all hooked up. Luckily, I was able to get some old computers from work, and I just had this whole line of computers, whole line of robots. My basement just looked like a robot area there. I mentioned the audio was tricky. I don't know if I would do the audio again. I mean, it was interesting because I didn't think about the whole timeline thing when I created the project, but it ended up being that it was a problem-solving task, right? So it wasn't awful, and it made the kids think of, how do I solve this problem? How do I make it to sync things up? So that was just something to think about if you want to incorporate audio into anything. Sensors. So I did have the students, when they designed it, they had to pick some sensors to add to it. And after we did the dance party project, the last 2 weeks, we did have some synchronous classes where I had them code some of the sensors. And so that does really require, at least from what I've seen and done so far, you need a person to trigger the sensor, right? So when you're working with sensors, you do need a little bit more synchronous time so that you can like turn the lights on and off, or have something block it so that it stops, or whatever you're having, the distance sensor or the light sensor, whatever those sensors do. So we did get a little bit into that. We didn't spend as much time on that just because it was getting towards the end of the year, but it does require that synchronous piece. And I guess the biggest thing, especially in the spring, was I just had to be flexible and adapt as we went along the way. And so I was sort of making up, I think I was like 1 step behind everything BirdBrain was doing, trying to follow along and get things ready for my class so that they could actually program these robots. But I had some students. Now the example that I had shown, that was a student that was like super into it, high level, spent probably a lot more time than he was required to work on this project. I had other students that just struggled with virtual in general. And so what I ended up doing was like I cut back and they like only did 30 seconds of the song. And so I just tried to adapt to what the students needed. Some students needed more help sessions. Some students hardly needed to check in at all. And so being able to be flexible and adaptable was really important. And as we go forward, it's still going to be important. So I have a few more notes on my last slide here about where we're going, I guess, in the fall here. If we can move to the next slide. So my school, as of today, and who knows, this can change as of tomorrow, we are planning to return to campus on September 2nd with the students. We do have a virtual schedule ready to go, though. So we have 2 schedules built in, and if things change, whether it's before school starts or in the middle of it, there's sort of an altered schedule where they will be virtual. When on campus, though, we have a ton of limitations still. I mean, I went into school last week, and I mean, the way that the desks have to be spaced out, any collaborative spaces have these weird plexiglass dividers now. So there's a lot I'm still going to have to adapt, and a lot of these virtual tools I'm probably still going to have to apply, even if we are physically on campus, because they still can't be near each other, basically. So even though we'll have the robots there might be some tools here that I'm still might need to use. And we have told families if they don't feel comfortable coming in, I might still have students that either have to be quarantined because they've been exposed or have it. So I still want them to be able to participate in the class. And so that virtual aspect still might come into play there. And then again, if virtual, if we know we're going virtual and I'm able to give my students kits, the goal is that I would like to, depending on how many students I have in the class. If I'm able to have one-to-one, then I will. If not, I will probably go back to using the Nets blocks again with remote robots. And now that I've learned a bunch of things, hopefully I'll be able to take that knowledge and kind of just improve on what I did in the spring and go from there. So I'll pause here again. I think that's the end of my section, and open it to other questions if there are some in the chat there. Is there anything I've missed so far?
There was a question from Joe. He said, and from Sam. Sam really acknowledged something. He said, "There's so many hypothetical situations. It's so hard not to think about each of them, and you just kind of have to take things as they come." So like huge acknowledgement of that, Sam. But Joe had a question, sort of a situation. So if you go back, how are you handling students in a group of 3 building a robot if they can't being in close contact? Like, I guess this is going to be a very sort of particular answer to what your school is allowing, what your state recommendations are allowing, and what you yourself are comfortable with. So it's kind of a personal question, but how are you going to have 3 students work together? What's that going to look like in your classroom?
Yeah, it's probably not. It's going to be the short answer. And to be honest, I'm trying to get discussions going because I think my administration hasn't thought through that quite fully yet. I think they're focusing more on the core classes and stuff and sort of figuring out what those look like. But I said, well, what about robotics? What about this? I'm fortunate that we just bought 18 kits, so we have a full class kit. So I will probably have them have their individual ones. And even if I have more than 18 kids, I actually have the old kits, like the original Hummingbird duo. And so if I have to, I will bring those kits out. And so I'll just have to kind of go back and forth between the old and the new in terms of that. Usually when I'm in class, I usually only do groups of 2 anyway, just because just holding the accountability piece. And I just find that pairs work often better than large groups with the on-site presence. But I mean, everything's changed now. And so my goal is to do it one at a time. I know that the students have like these little shield things now too, but even at that, it's like if you have one robot, how do you have 2 kids working together? And what I can imagine is maybe you have 2 tasks going on where maybe one kid works on it and the other half of the class is working on something else independently. Maybe you have to do something where it's like a stations activity where you have them set up, and even though it's 2 kids for one robot or 3 kids per one robot, maybe they somehow have to do some sort of rotation in terms of working on the robot if they are not allowed to have any close proximity to each other. That would be my thought if that becomes the case for me. If I didn't have enough robot kits per one student, would do some sort of rotational of a kid works on it and then the other half are doing something else, and then that way they're working together, but they're kind of swapping off the time spent on the robot.
I did, there's a couple of questions in the chat, which probably other people have as well, which is like, how do if I'm gonna have multiple students use it, is there a way to wipe it down? Is there a way to clean it in between students? I bet you can imagine that's a lot easier to do with the Finch because it's got a nice smooth surface on it. You can wipe that down a lot easier. But I posted in the chat how to clean your robot. We do have some guidelines to help you be able to clean your Hummingbird and your Finch and disinfect those in between student uses. If, like someone was saying, like Danielle was saying, that her admin is saying that when they do return, they won't be able to have any shared technology. So, you know, potentially that means they have to be kind of one-to-one, or only one student is touching the robot with their Chromebook and the other students are collaboratively programming it or something. Yeah. Like
and the other thing you could do too is, depending on how long of a time you have with students, is rather than having 2 students per one robot for one project, maybe you split like the semester. Maybe the first half of the semester you have half the kids working on robots and the other half of the kids are working on a different project, and then you switch halfway through the trimester. So it's always that same kid with that same robot all the time, because that's a good point there. I appreciate the how do I clean, because I've got to figure that out too. And the other part too that I have to figure out, because my area is in this makerspace area, which again we're trying to figure out how that's going to look. But what it might be is I might have to place bins on tables and say these are the only materials you get to use, and these are the only materials this table gets to use. And that way we're not going everywhere with them. They're all at one table. At the end of class, they clean those tools off. Because normally they're all over the place on the workbench, over by the printers, like they're everywhere. And so there's going to have to be some new rules in place and some new protocols in place to make it all work.
Danielle had another great idea too. She said, might you have some peer leaders make the remote robots and then coach other newer students? I think this question of how do we get students to work together where only one of them can touch the robot is really a classroom management question, and one that like we all probably have some great ideas on. I think that's a great one, Danielle. But like rethinking roles in groups, how, you know, there's been traditional, you can split kids up in groups and be like, okay, you're the recorder, you're the videographer, you know, you're the programmer right now, you're the builder, like splitting those roles up, and then they have those roles for the day, and then you wipe things down, and then the next day they transition roles, and now, you know, the next kid is on there. And again, with a finch, you just grab a Clorox wipe and kind of wipe it down and you're good to go. But Pam was also saying that since they're going hybrid with half our students each day, she's considering pairing a student from each cohort who otherwise would have no interaction, which is a really good point to bring in, Pam. How do you get these cohorts of isolated students to, you know, not feel isolated? So she's considering pairing up a student from each cohort so that one can program the code on Microbit Classroom at home, and the other can build the robot in school. So that's also a great way to bring separated cohorts together through creative robotics. So I'm always consistently impressed with just the solutions that teachers come up with to these novel, interesting problems. Heartbreaking problems is another way to say it. But you guys are the creative geniuses of your classroom too. So like, be bold, do something weird, it'll be great.
Yes, and use each other. I mean, that's how I find out how to do things. I'm just like constantly reaching out to other people, see what people are posting on Twitter and Facebook, and even in my local area, what other schools are doing. And so just getting the best from everyone else, and then figuring out what works for you, because every teacher's a little different, and so you have to figure out what works for you that's going to work for the school, right? So what are your restraints, and then what's going to work with you, your personality, so that the students still have that connection with you, and that you're still able to present and to have this curriculum to the best of your ability. And again, that was my biggest thing, is how can I have them program, make robots without losing the core things of what this class was all about to begin with. So,
all right.
Well, I'll turn it back over to Tom now. And if there are more questions, I mean, at the end, I'm sure we'll have more time for questions, but I'll keep an eye on the chat as well. So.
All right. Thank you, Erin. And I almost feel bad about ending this discussion, because it's just great to see the number of suggestions and comments and just creative problem solving going on in the chat. I did turn off the smart house just now because it was making a lot of noise and I didn't want to necessarily talk over it. I was muting myself most of the time, but it was fun to see all the robots moving around here in the studio. So I'm going to briefly do an overview of 3 ways that you can make remote robots or work in this situation. And so the first way is NetsBlocks, which we've already talked about. I want to get into kind of a few of the more technical details about how it works and how to use it and the advantages and limitations of this. I'll also talk about Microbit Classroom and about Zoom remote control. So I saw some technical questions coming in through the group chat. I think mostly I'm going to address those questions just by going through the presentation, but if you do have questions, there'll be another period at the end of the presentation where I can answer more. So I tried to come up with sort of the one-liner, right? So what is NetsBlocks? What is like Microbit Classroom and MakeCode? What is Zoom? So for NetsBlocks, it is just a magical way to do live robot coding remotely. So it allows you to, over the internet, click on a block, and then through that camera, you can see it happen in real time. And that really does feel magical to me, and it's really exciting. It works with all versions of the Hummingbird and the Finch 2.0. I can make it work with the Finch 1 if it is requested. So if people ask me, I will do it, basically. So let's talk about how it works. like I already said, NetsBlocks is based on Snap, which is based on Scratch. So you've already seen the interface now as part of the kind of demo. The way that works is that every project, every time you open a NetsBlocks link, it sort of registers that project with the NetsBlocks cloud server, and it has a unique name. And projects send each other information. They can, like, one project can send information to another project using those names. So when you open the student link or the client link, which you did for the demos, which somebody's doing for the Beetle, that student project already knows the teacher's name, the teacher project's name, the one running on the robot here. And then once you connect, the student project basically tells the teacher project, hey, this is my name. So that way you can have bidirectional communication, because now both projects know each other's names. So essentially what's happening is, you as the student click on a block, like move the position servo on port 1 to 35 degrees. And then over the internet, that goes to a project running on a laptop here in the studio. And it's sending it the information about which port and what angle and to move a servo. And then over Bluetooth or USB on the local laptop here, it's sending that information to actually move the servo on the robot. What's cool about this is it is bidirectional. So if you have a sensor here on your robot, you can send information to Bluetooth or through Bluetooth or USB to your project here locally. And then over the internet, that gets sent to the student project so that when they click on a sensor block, it tells you what that sensor value is. So that's the very high level overview of kind of how NetsBlocks works. So what that means is there's no security issues. You don't have to open ports on your wireless network. You don't have to give people control of your computer. There's essentially no way to hack this system unless you give out your NetsBlocks user ID and password. Then you're in trouble. So then how to use it, right? So Erin talked about the asynchronous case, which is, you as the teacher set up robots, connect them to your local computer. You point a camera at those robots. You mute your camera. This is important if you're doing this asynchronously. And then you create a live stream with that camera on YouTube, with Nest Cam, with Facebook, like we're doing Facebook live streaming right now, Twitch. And then you send the links to program the robot to the students, as well as the link to the live stream. So that's how you use it in an asynchronous situation. Synchronously, it's very similar. You set up the robots, you connect, point the camera at the robots, and then hop on video chat with the students and send them links to program the robot. And that's exactly what I did for the demo session at the beginning of this webinar. So the advantages of NetsBlocks are live coding, and that is not to be taken lightly. When you can live code, it means that students can click on individual blocks or set segments of blocks and instantly see what happens. Or if it's over a live stream, it may take 15 seconds, but it's still pretty fast. So they can quickly iterate on their code and improve it. Students can use any device that runs a Chrome browser. So that includes iPads, Android tablets, whatever. It's secure. You can, with a Hummingbird Kit, one of the issues, Erin mentioned this, is like if you have a servo and you're moving it out of range, where the piece of cardboard you have stuck on that servo might hit something else in the robot and cause it to be damaged. You can actually, on your end, limit how far the servos move. On the finches in the arena here, I've actually limited their top speed so they don't go as fast as they could go because it's only 4 feet across here. So you can do these kinds of things on your end, and the students basically can't do anything about it. There's no way for them to access that side or change it. And then one thing that's cool about it is you can do 24/7 operations. So since I think March 30th, I've been running remote robots at my house. There's a link there to 5 robots that you can program after this webinar and at any time in the future. And they've been up pretty continuously since March. So if you are from a science center or a place where you might want to have an exhibit, this is a really cool virtual exhibit idea. It takes a little bit of checking on the robots from time to time. To be honest, in In my case, my biggest issues have been a Wi-Fi connection going out, like Wi-Fi to, you know, the third floor robots sometimes going out, or Windows deciding it needs to update because I'm running off of Windows laptops. So stuff like that. The robots themselves and the connection over NetsBlocks has been very stable. Now the limitations, the setup, as Erin mentioned, it took her about an hour. And so I do think that it requires some moderate coding experience with blocks programming. So moderate Snap or Scratch experience. You don't need to have any Java or Python or text language experience to set this up, but it does take a little bit of time. And I have noticed that with NetsBlocks, loading files occasionally is buggy. That is something on the NetsBlocks end that I'm hoping gets fixed soon, but I've seen cases where you load a file and it just goes blank in the browser window. And then the other issue is, you know, if students are on a smaller device with a smaller screen and they want to see both the robot and the program, that's going to require some resizing of windows. And finally, we talked about the delay already. So that's sort of the quick overview of NetsBlocks. There is a deep dive on how to make your own robot using NetsBlocks right here. And that takes you to a tutorial, basically an upgraded tutorial of what Erin used to make her remote robots. Okay, so let's talk about MakeCode and Microbit Classroom. So to me, these two tools are really excellent collaboration tools for both remote and one-to-one robotics. So both situations where you're the only one with the robot as the teacher, and situations where all your students have robots, but you need a collaboration tool. So I'm going to talk about this primarily from the perspective of remote robots, because that's what this webinar is for. So it works with any product in the ecosystem. And let's talk about kind of how it works. So MakeCode programs download directly to the microbit. And that is often both a feature or not, depending on your situation. But what it means is that there's no live coding. It also means that once the program is on the microbit and on the robot, it runs independently of anything, of any computer. It just runs until you turn it off. But because there's no live coding, you have to have your students essentially iterate on their program. You need to download the code to the robot, and then you need to show it to them somehow. So there's two ways to do that. If you're in a synchronous situation, you can use Microbit Classroom, which allows you to see the code as the students are editing it. So sort of like Google Docs a little bit. If you are in an asynchronous situation, you would use just standard MakeCode, and there's ways to have students like publish their project and share the links with you to see what the code looks like, or they can send you hex files, so they can just send you the program. And then you will need to download that student program. So again, asynchronously, what you can do is share links to partial sample code. You can use a learning management system. Microbit has a nice tutorial on how to do that, to send them that sample code and essentially give them an assignment like here, fill out this sample code, or add this to this sample code. And then the students send back your completed code, and then you load the code on the robot and take a video of the behavior to send to the student so that they can see if they've made a mistake or not, or if it does what they expected. So that's sort of the asynchronous use case. Synchronously, you can set up a Microbit Classroom session and invite students, and then you can send sample code to all the students within the session. You can also show one student code that another student has written. It's very nice, actually. It's a nice interface. And you can see these programs as they are creating them. So it's not like, it's basically like Google Docs, where you see every movement that somebody makes. And so then when the student indicates that their program is ready, again, you load the code on your robot, and then you show the student the program running. All right, so the advantages here, you can see student code live with Classroom. MakeCode also can convert to JavaScript or Python, so you can go a little bit further in terms of text programming. And you can use link sharing, and that is useful in that you can integrate that with learning management systems, and they have a tutorial on it. But the limitations are, the teacher, you as the teacher, at least in the remote robots case, you have to download the code to the robot every time the student changes it or wants a change. And so what that really means pedagogically is the student needs to conceptualize the entire program, which kind of limits how big a program can be. If you've ever just tried to write a program to do something from scratch, there's kind of a limit at which point you kind of run out of like the ability to see the whole thing at once. You need to be able to test and iterate in order to really make progress. So I think it kind of limits the size of the potential program. Again, I've written a deep dive for how you would use MakeCode with both Microbit Classroom and with learning management systems. Mostly this sends you to Microbit's own resources because they were excellent and I don't believe in reinventing the wheel. All right, so the third method is very simple. You can use remote control via Zoom. And so here, like the tagline is, it's a flexible method for one-on-one tutoring. Why? Because only one student can do this at a time and only in live sessions. But it works with any robot. Anything you can connect to your laptop or iPad will work with this. So how this works is you connect a robot to your computer, you load the programming interface, and then you give students remote control of your computer. And if that gives you a little heartburn, I understand, but this is, it can be nice. It can be a good technique. Oops. So where I would use this would be in very small group sessions, probably 3 students maximum, because again, with Microbit Classroom or MakeCode or NetsBlocks, all students can be writing their code, even if only one of them is connected to a robot or sees the code running. Everybody can be busy thinking about how to write it and writing the program. Whereas if you're using remote control, only one student can even be writing the code, much less connected to a robot. So you definitely want very small group sessions, technical support, and I would recommend that if you're using Zoom, you use an interface that provides live coding. So I would use it for something like Snap, in the case of Hummingbird or Finch, not necessarily use this for MakeCode. All right, so the advantages of Zoom: it's easy, it works with any programming language or robot, and you can do live coding and iteration. But obviously there's a security risk. Only one student works at a time. And Zoom remote control currently doesn't work on Chromebooks. So if you only have a Chromebook at home, then you're gonna run into some issues with this too. And there's no way to do this asynchronously. But here's the instructions on how to do Zoom remote control. So yeah, that's sort of the quick overview. Really, I mean, I was trying to just talk through these different methods and highlight their advantages and limitations and where you might use them. If you want to learn more about any specific one, all 3 are linked off of this Remote Robots Overview link. And then, of course, as I mentioned, we are doing a whole series of webinars. They have mostly not been scheduled yet, but do check that link in the coming week or follow our Twitter feed for webinar announcements. I mean, we're here to help in this sort of remote learning future or present that we are in. We want to make sure that if it's possible for kids to program real robots this year, then we want to make that happen as much as we can, right? So that's our aim, that's our goal, is to let's not have this crisis cause kids to lose out on this kind of important learning opportunity. All right, so any questions come in while I was talking? I was not able to monitor the chat while doing that.
There was one question about if students are on Chromebooks, like basically which devices each of these works with. So with NetsBlocks and Microbit Classroom, that works with any device, right? Laptop, Chromebook, iPad, etc. But with the Zoom remote control feature, that does not work with Chromebooks. So if you are on a laptop and your students are on a Chromebook, the Zoom does not recognize Chromebooks as a valid person to give control to. It's very biased. So that feature does not work with Chromebooks if your students are on Chromebooks.
Okay.
Oh, and Erin just shared her contact information, her Twitter handle, and also her email in the chat. Would you like to share those verbally as well for people watching on Facebook, Erin, or do you just want to limit that to who was here in the chat and the Zoom today?
No, it's all public information anyway. So my Twitter handle is @WhitakerErin, so last name, first name. And then email is ewhitaker@sewickley.org. So you can find that on the Sewickley website if you forget or need to find me. So yes, feel free if you have any further questions about classroom implementation or just want to collaborate and talk through ideas. I'm happy to do that.
Been an amazing resource for us to have to show that like it's not only possible but joyful to do robots at home and to persist and survive in this very strange landscape we find ourselves in. Thank you so much for being here, and honestly for the like revolutionary teaching you're doing with this, Erin. Like, you are on the forefront of you're showing people what's possible. You're a trailblazer, and just amazing.
Well, thank you for the opportunity. It's been great to be able to collaborate with you guys. And like I said, I mean, it saved my class figuring all this out, because otherwise I would have had to do something totally different. So it's been a great partnership, and I'm sure great things will come going forward too. So
yeah. All right, did any other questions come in, Kelsey or Matt?
There was one about a GitHub workflow. Have we deployed a GitHub workflow for remote robotics?
No, we haven't. I can look into that. I'd be interested in looking into that. Okay. All right, well, if there's no other questions, I mean, we are actually a little bit over time anyhow. Thanks so much for coming. Thanks for playing with the robots. Thanks for listening. And I hope all of this has been useful for all of you. And hopefully we can keep making and physical robotics and physical computing going in this coming year.
Definitely stay tuned on our professional development page. If you go to birdbraintechnologies.com and you head to our professional development page, you can see what we have coming up. There's not much listed right now, but stay tuned there, because as Tom alluded to at the beginning of this webinar was specifically focused on remote robotics, where you, the teacher, have the robots and the kids don't, and how you can make that work. But we're also going to be working with a few other people who have been doing like the one-to-one model, where the kids at home have a robot and we have a robot, the teacher has a robot with them as well, and talking about some best practices similar to how Erin did about remote robots, talking about that one-to-one model. So stay tuned, because there's going to be a number of those coming up as well. Again, just to help you figure out, how can I make this work in this sort of impossible situation we have coming up? How can we still have creativity and joy and coding in this weird new world? So stay tuned, because those webinars are going to be coming out over the next few weeks.
And with that, I'm going to go ahead and end the live stream. Thank you so much, everybody.
Thank you so much for joining us today. We can't wait to see what you make on social media. On Twitter, Instagram, and Facebook, you can tag @BirdBrainTech or #Hummingbird Kit, or you can even tag me. If you have any questions, be sure to email us, info@birdbraintechnologies.com. We can answer questions about purchasing, about learning, about teaching, and about professional development. If you haven't been there yet, be sure to visit our Robotics at Home page. There you can purchase a kit for yourself, learn how to use it, and even join one of our upcoming webinars. Until we see you in class, thanks for watching from everyone at BirdBrain Technologies.